Hi, this is a video about calculating percent yield. So percent yield is when we look at how much product, so we're always looking at the product side of one of the products, how much are we getting compared to theoretically how much we should have gotten. So for example, here's an analogy, if I have 30 total kernels, theoretically all 30 should pop, but in reality they don't. So if you count here, I think there's 8 that didn't. So we would have 22 that popped. So when I take the actual yield, what I really get divided by what I should have got, the theoretical, and multiply it by 100, then I get what we call the percent yield. Most percent yields are, so this is like 73%. Most percent yields are less than 100% because usually you lose some of the product, like some of it will stay on the stirring rod, or, like when we did our lab with the copper, some of it probably got poured through instead of being all staying in the beaker. However, in labs, there are also times when the percent yield is higher than 100%, and it's not that we actually created more than we should have, it's just that it's a lab where we would have had to dry something, so then the water maybe wasn't all dried out. So I want you guys to take out that lab, and I want to do some of the calculations and explaining while using your lab. So pause the video, go find it. So first thing, we did talk about this already, but here's the definition of what theoretical yield is. It's the maximum amount of product that you would be able to get in theory. So this is always based on stoichiometry calculations. So for your lab, this corresponds to number 7. So using whichever balanced equation you think you have, you're going to determine the theoretical yield of copper, starting with your amount of iron. So for me, let me use my data. I had 2 grams of iron. So I would want to convert that into grams of copper, and that would be theoretically how much I should have made. So I'm going to let you guys take your value and calculate it out. So pause the video and do that. Okay, so hopefully you've had a chance to do this calculation now with your amount of copper that you're starting with. We would have converted to moles. Then we would have done the mole-mole ratio, depending on your, whichever reaction your data brought you to. So let me get my picture out of here. It's always in the way. So if you picked the 1-to-1 reaction, then this would be your stoichiometry step. Otherwise, it's going to be the 3-to-2 step. I did the 1-to-1, and when I did that, then I ended up with 2.23 grams of copper. So your answer is going to be different, but similar to me. So this would theoretically be how much I should have formed of copper. My actual yield of copper is what I got after I subtracted this value from the beaker. So I'm going to let you guys go to your lab. If you haven't already calculated this value, which is really the actual yield of copper, how much copper did you make? I'll let you guys do that and come back. So I'm not sure what your data looks like, but for me, these are my numbers. When I subtracted, I get 2.13 grams of copper that I actually made in the lab. So then if I want to calculate percent yield, then I'm going to take my actual yield, which I just got, the 2.13, and yours will be different than me, and I'm going to divide that by the 2.28, what I should have gotten based on stoichiometry. So when I do this, I got a yield of 93.4%.